Welcome to today's video on section 2.1 for geometry, inductive reasoning and conjecture. Inductive reasoning is a reasoning that uses specific examples to arrive at a conclusion. A conjecture is a concluding statement reached by using inductive reasoning. So those are two definitions that you need to know before we start going through the examples. What inductive reasoning is, what a conjecture is. So inductive reasoning is the process, the conjecture is what you're going to come up with. So the first statement here, and let me make it a little bit bigger. There we go. The first statement says write a conjecture that describes the pattern 2, 4, 12, 48, and 240. Then use your conjecture to find the next item in the sequence. Well, if you notice, here you're multiplying by 2, then times 3, then times 4, then times 5. So basically to find the next item, you would go 240 times 6, which equals 1,440. That's what the next item in the sequence would be. The conjecture is that if n is the term in the sequence, like the first, second, third term, then to find the nth term, or sorry, you'll take the nth term and multiply it times n plus 1. So for example, to find 4 is the second term, or sorry, to find 12, you'll take the second term, which is 4, and times it by 2 plus 1, which is 3. So 4 times 3. So then the third term, which is 12, you'll take 3 plus 1, which is 4, and multiply 12 times 4 to get 48. So this is your conjecture. For B here, notice here you're adding 6, here you're adding 9. So you started with adding 3. So you go 3, 6, 9. So then the next one would have 12. And the next one would be 30. And then basically your conjecture would be the nth figure increases by 3n plus 3. So notice the first figure increased by 6 to get to the second one, because 3 times 1 plus 3. The second figure increased by 9 to get to the third one, and the third one increased by 3 times 4 plus 3, which is, or sorry, 3 times 3, which is 9 plus 3 is 12. So that's how you get that conjecture. So now part A says write a conjecture that describes the pattern in the sequence. Then use your conjecture to find the next pattern. Well, notice the next term is equal to 1 over n squared, where n is the next term. So notice for the sixth term, you would go 1 over 6 squared, which is 1 over 36. So therefore it is B. Then it says write a conjecture that describes the pattern in your sequence. Then use your conjecture to find the next term. Well, here, if you notice, you go from adding 2 3, then 4. So basically, when you take the nth term and multiply it times n plus 1, so like the second term is 3, and you multiply it by, or sorry, you add it to n plus 1. So 3 plus 2 plus 1, which is 3, it gives you 6. So the third term is 6 plus 3 plus 1, which is 4. That gives you 10. So the 10th term, or sorry, the 10 is the fourth term, so 4 plus 1 will give you 15. And that makes the next circle figure will have 15 because you're going to add 5. All right. Write a conjecture about the sum of an odd number and an even number. List some examples to support your conjecture. Well, for example, 3 plus 4, that gives you 7. 5 plus 2, that gives you 7. So notice an even plus an odd is going to equal an odd number. For part B, it says for points L, M, and N, LM is 20. So from L to M is 20. MN is 6, and LN is 14. Well, notice 6 plus 14 equals 20, so that means N has to be in between, which means that your conjecture could be that L, M, and N are collinear. It says make a conjecture about the product of two odd numbers, like 3 times 5, notice is 15. 7 times 9 is 63, so it's odd. Given ACE is a right triangle with AC equaling CE, which figure would illustrate the following: that it's isosceles, meaning two congruent sides, a right angle for C, and A is the hypotenuse. Well, here notice EC is the hypotenuse. That doesn't work. This doesn't have a right angle, so it's just between B and C is the only one that has these two sides congruent. So therefore it is C. All right, next page. It says the table shows the enrollment of incoming freshmen at a high school over the last 4 years. The school wants to predict the number of freshmen for next year. Make a conjecture about the enrollment. Well, if you notice, it goes up 24, then goes up 26, then goes up 25. So if you notice, 50 would be too much. It's not decreasing, it's going up from year to year, so C would not be. It's not staying the same. And notice if you average it, here it's 25, so the enrollment would increase by about 25. All right, before I go to the next one, I'm going to talk about a counterexample. A counterexample is basically an example that you'll use to show a conjecture is false. So basically, it's an example to show that a conjecture is false. So, if you look at this one up here, it said, based on the table showing unemployment rates for various counties in Texas, find a counterexample for the following statement. The unemployment rate is the highest in the cities with the most people. Well, the cities with the most people is El Paso. It's 7%. But if you notice here, the unemployment rate is 11.3, and Maverick does not have the most people. So the counterexample is Maverick has less people, So Maverick has less people then El Paso yet has a higher unemployment rate. So that's our counterexample.